Jordan. I'm with a company called Centramatic on-vehicle wheel balancers. Mike Beckett with MD Alignment. We're here to talk about the advantages of balanced tires and proper alignment. Centramatic was established in 1985. We began supplying the trucking industry with on-vehicle wheel balancer assemblies. We have 2,500 plus dealers nationwide and growing, and it is an American-made product. We have Centramatics are available at dealers like Love's, Speedco, Packard Parts, Peterbilt, Freightliner, just to name a few, Petros, TAs, and like Truck Stops of America, Goodyear's. We have several dealers nationwide. Just to name a few, this is just like I say, a few of the dealers that we have. We have many more. We just listed a few of them here. So this is like an assortment of the Centramatic balancers we carry for the heavy-duty trucking side, from anything from a 19.5 all the way up to 22 or 24.5s. We also do some medium duty, which is the 3/4 ton pickups, 1 tons, dualies, F450s, 5500s, and some of those also. And what the Centramatics do is we're balancing everything as one assembly. Like right here, replacing tires sooner than you should. You got a cupping tire from not being balanced, or you got like the tire that's on the other side is 221,325 miles on that tire. They pulled it off and put it on their trailer to finish it out. So what the Centramatics will do is balance everything as one assembly. We balance the tire, the rim, the hub, the drum, all the way down to the wheel bearing, or the disc, or the rope, whatever's moving. There's several methods that the person can use for balance. Number one, you can ignore it, and all you're doing there is spending money, spend more money on tires, and you're wasting your tire life. Number two, a good balancer is spin the tire on a spin balance machine. We've all seen that, where you get the tire, you mount it put it on a spin balance machine. You always have to go back every few times and rebalance. And when you load it to the truck, the rest of it's not balanced. The better form of that is where they used to spin balance the tires on the truck, and that balanced everything as one assembly all the way down to, when it was on the truck. The permanent solution and the best solution is the Centramatic. As your balance points change, the Centramatic will balance it out, and they'll change with it. Mud, snow, ice, rocks, anything packs in the wheels, well, the Centramatic will balance that out. It's always adjusting and rebalancing while you're in motion. You never balance again, as long as you've got a good alignment and the tires are mounted right, the balancer's there to stay. They've got a 5-year unlimited mile warranty. 5-year warranty. We don't care how many vehicles they've been on. We have seen the Centramatics balance or stay on the vehicle up to with 2 million miles on it, still running. We have some in our display at our shop. They found some in California. I think the last show they done, I think was 27 years old and still working. So we don't know when they wear out. In my years of being there, I've never replaced a wore out set. I've warrantied some for other things, but very few. Our warranty rate is very low. It's less than 1/4 of 1% of what we sell. The balancer, it does work. This just shows you a little bit about how the balancers work. You've got the heavy spot on one side and all the media on the other. And then when it's not like that, you don't have a heavy spot, well, the balancers will just spread out evenly. And as your balance points change, as I said, they will also constantly change with it. So we're balancing everything, mud, snow, ice, rocks, anything that packs in that wheel or anything we can balance. And as it slings it out going down the road, it'll also rebalance. You don't even know what's happening. This is Gave us this one, we skipped. Okay. So, what the data has showed that we've come up with is we increase your tire life a minimum of 25%. Reduces the vibration, less driver fatigue. The mirrors are not sitting there rattling all the time. The hood's not bouncing up and down. We had some trucks that I dealt with that had some hood hinges that were breaking on the hood, and they put the balancers on the trucks that had the balancers. The hinges were not breaking the hood because the trucks weren't sitting there slamming on the pavement, they were rolling on the pavement. That was just a plus for us. But the Centramatic will increase your tire life a minimum of 25%, up to 50%. We've had some real good success with it on different applications. Construction trucks all the way up to highway trucks. You know, some of the logging trucks and stuff like that where they pack the mud in the wheels, and they really get hammered pretty good with the mud and stuff that packs in the wheels, and this is the only thing that'll balance them out. We have a fleet guarantee program, which we have in the book, that would guarantee you to get 25% increased tire life. We have a few things you have to do and check your 30 seconds at your PMs and what have you, and you will see the increased tire life. You'll see it for yourself in your fleet or your trucks. So we guarantee the product to work with a money-back guarantee. All we need to know about your vehicle to get them on there is the year, model of the truck, make, model, such as Peterbilt, Kenworth, W900, or what have you. The size of the tires, the number of the studs, whether it's an aluminum wheel or a steel wheel, disc brakes or not, and the bolt circle. Is it 8 lug nuts? Is it 10 lug nuts? We fit, like I say, anything from a 3/4 ton pickup up to an 18-wheeler, buses, motor homes, different things like that. I know I've kind of went through it kind of fast. Does anybody have any questions so far? Anybody? Can't see you, but.
There's a mic in the center of the room that's hot for questions.
Okay.
Question: why is your product better than like using beads in the tire?
The difference in me or something that goes inside the tire, I'm a once and done balancer. In other words, you put it on one time, I last the life of the vehicle. You don't buy it ever again. The other thing is I balance more weight. So I'm not just balancing the tire, I'm balancing the tire, the rim, the hub, drum, or disc, all the way down to the wheel bearings as it's moving. And as your balance points change, the Centramatic will change with it and balance it. We balance 16 to 18 ounces up to on the steering axle, 28 to 32 on the duals or drives. On the set of duals, I got the best thing for balancing duals or a trailer or drive, for the simple fact you got 2 tires, you bolt them together, you change your balance point. I balance everything as one assembly, and I make everything run as one assembly.
Okay, and what about the cost comparison between like beads and your product?
You know, if you look at the beads, they're going to be cheaper when you put them in at first, but every time you open that tire up, you're going to buy another bag, do all that with the labor and all this. You know, with the Centramatic, it's once and done. You last the life of this vehicle, whatever you would operate it, and I can balance more weight, and it can go off of this vehicle and put it on your next. Like I said, we got them on the road that are still running. We hear it all the time, up to 26 years. The guy's still running the same set he bought originally.
All right, appreciate it.
Thank you.
Drive buses and highway speeds are fine, city speeds are fine. 45 miles an hour shakes like the Dickens. Are you saying that this is going to smooth that out?
If it is balance related, it will smooth it out. I put them on tornado bus lines. We had some buses running out of Houston and ran Chicago, and they slip seated them. They just ran straight there, turned around, come straight back, never shut off. They were getting 25 to 30,000 miles on some of the Hancocks or the Continentals on the steering axle. We tripled the tire life on the first set we put them on. And then they've done some alignments and took care, you know, it's not, Centramatic is not like a mechanic in a tube. You know, if you got a mechanical issue, you're still gonna have it. So therefore, like when we come out, we talk to you about your fleet or your coach or your unit. There's always some questions we ask. you know, and we want to know more about your coach. We don't run from anything. We're here to help. You know, we might even send you somewhere to do something that has nothing to do with Centramatic. My goal is that your tires last longer. Whatever it takes to do that, that is what we're here for.
Appreciate it.
Anybody else? This gives you a picture of what the balancer looks like behind the wheel. So you would pull the tire and wheel off, slide this over the hub assembly, and put the tire and wheel back on. It's permanently on the vehicle. As you can see through the hole in the wheels, you can see the tube in there. That is the actual balancer. So the Centramatic is made of galvanized steel, and it runs an aluminum tube. And inside that tube is what we call durametal. It would look like buckshot or birdshot, but it's 10 times harder and runs in a synthetic oil. This is a Ram 4500 with a hot shot rig we put them on. This is a little video. This shows how they mount. They're real simple to install. Same theory on a truck or a bus. And we always recommend when you put them on to always torque them back to the manufacturer specs. Just like any other time you would mount a tire or do anything else. This gives you a little picture of how they look when they're mounted on the dual or the drive. We also have them for super singles, which we don't have a picture of that, but it's the same way. Mount, you pull the tire and wheel off, slide them over the hub assembly and put them back on. On this next slide, you'll notice we got the two arrows, so the two holes in the balancer, so you can align the valve stem, so you can always get to the inner valve to check your air pressure. That's what it's showing you there. Always make sure you get to that inside valve stem. So, pretty much like I say, Centramatic is a permanent onboard balancing system. Increase your tires up 25 cents, 25% or more. Reduces vibration, which helps with driver fatigue and different components in your truck lasting longer. Extends the chassis of components such as airbags, shocks, any of that thing that's not beating on the highway, it's actually rolling on the highway. And we are time tested. Like I say, it's got a 5-year unlimited mile warranty. Anybody got any questions? If not, I thank you for your time. Go. Right now we got a show special of $199 per axle. And one set does one complete axle. So it would be a right and left or dual. On the drive would be the same. You got 3 sets on the truck if you got 10 wheels on there. And like I said, they will pay for themselves with their first set of tires. You'll notice an increase in the way the truck rides and drives and handles. Less rolling resistance on the highway and the truck will ride and handle better. Yes, sir?
I have a set of Centramatics on one of my axles at least, but this is the first time I've heard, did I hear you say that there is actually synthetic oil inside of those?
Yes, sir. There is synthetic oil in there also, which helps with rust inhibitors and makes them last longer, keeps them a little quieter.
How does that affect cold temperature movement of the media?
We don't have any trouble with that. They start gelling up around 60 below zero. At 60 below zero, we're not running 70 miles an hour.
And also, I can't say I've ever seen one of those leak or anything like that. What do you do to ensure there's no fluid leakage?
I'm sorry?
What do you do to ensure there's no fluid leakage?
Everything's in a controlled environment in the tube, so there's nowhere for it to leak. If one were to leak, that would either be warrantable or something damaged the balancer to make it leak. Like I say, we don't have an issue with that.
Thank you.
Thank you. Anybody else? We thank y'all for your time. If you have any questions, we're in booth 14088. I can do demonstrations, I can show you. I've got brochures and all, which I should have brought with me, I did not. But we're in booth 14088. I'll turn it over to Kevin now. Kevin.
Thank you, Ricky. All right. I'm Kevin Beckett. I'm with MD Alignment. We are producers of the MD Alignment QCT system. We've been in the alignment industries for, it's about 35 years now as a company. And we've been in alignment service. We provide equipment, we do training, we do seminars. We work with a lot of manufacturers, a lot of tire manufacturers, fleets, repair garages, work with owner operators. We have podcasts with the Lunch Truck Group. And this is an abbreviated version of our seminar. These little brochures here, these have QR codes to discussions of everything I'm going to be talking about here that expand on what I'm going to be saying here. So let's get right to it. There's a lot to cover in a little bit of time. All right, alignment. Feathered wear is the enemy of alignment. This is what we're trying to solve when we do an alignment. If you have feathered wear, you have an alignment problem. If you don't have feathered wear, but you have tire wear, you have something that is not an alignment problem. Feathered wear is the easiest way to identify it. Visually, is the description by the TMC is a step down across the face of the tire, usually covering the entire face of the steer tire. So as you can see, one edge of the tire is lower than the other. That's the leading edge of the push. The trailing edge of that push ends up with a feathered edge. If you run your hand across the steer tire, toward the frame, away from the frame, if you feel it sharp one direction but smooth the other direction, you have identified feathering. You have identified an alignment problem. If you have feathering on one tire but you don't have it on another tire, it still means you have an alignment problem on both sides. If you have feathering on both tires but they're in opposite ways, well, you've identified different alignment problems. Now, the most common issue is toe in wear, toe in, toe out. Toe in wear would be you run your hand toward the frame with the vehicle across the tire, and smooth toward the frame and sharp away. Smooth in, toe in. Toe out wear, the next most common problem, is when you run your hand toward the frame of the vehicle and it's sharp going in but smooth out. Smooth in, toe in, smooth out, toe out. Once you've identified that, you've identified most of the problems you're going to have on the track as far as alignment. Now, how is it that you can get a vehicle aligned, but you didn't have, when you left, you had the same problems that you had when you got there? That was the problem that we were faced with dating all the way back to the 80s, trying to figure out how to get a vehicle to be aligned when we were done. Not just get the measurements, but have it act out as towed in properly like we measured. One of the issues is every steering component has a certain amount of play. For instance, this is indicating, as it says up on there, the tie rod end, a good tie rod end has an allowable 1 millimeter of play in the direction of the load. That's the length of the tie rod itself. So if you can have a millimeter of play on each side of a tie rod, then you have 2 millimeters of total movement at the tie rod end. The tie rod attaches to the spindle at the acronym. The acronym is only about 7 inches long, but your toe measurement is measured at 44 inches, the width of the tire. So if you have 1 millimeter of movement at 7 inches, that plays out to as much as 1/4 of an inch of movement at the length of the tire. So just that 1 millimeter of movement in a good tire rod end can result in 1/4 of an inch of change in toe as the vehicle rolls forward. That's not the only component. The bearing itself is right there at the spindle. It's got a 3-inch diameter, 3 inches times divided into the 44 inches of the tire size. That means a good bearing with only 3,000 to 5,000 play, and can still give you about a 32nd of an inch of play in your toe measure. So how do we account for all this possible freedom of movement in your steering components as it relates to a toe measure? Well, first, the most important thing is to know how that play turns into toe. And that starts with the negative scrub radius. Negative scrub radius is the percentage of the tire that is outboard of the kingpin. So as the vehicle rolls forward, because there's about 2/3 more of the footprint outside the kingpin than inside, that means that the tire generally is trying to pull away from the frame of the vehicle. It's pulling away from the center of the axle towards the outside as it rolls forward. So if you can include that force in your measurement, then you can identify how much the play is turning into toe. The easiest way to do that is to roll the vehicle forward before you measure the vehicle. Don't jack it up, don't put it on turn plates, don't use slip plates, don't change the environment that it's in. Roll it forward, measure it right there on the ground. You have now included all of the play components in your measurement. If you're not doing that, you're not getting an accurate toe measurement. So that's the first, the most important thing. One of the most important lessons we've learned on alignment. Roll the vehicle forward and take your measurements right there. Sorry about that. All right, now let's say you've got feathering that isn't just toe related. In other words, you run your hand toward the frame on one side, and it's sharp going in. You run your hand towards the frame, and on the other side, it's smooth going in. Well, that's identified that the rear end of the vehicle is pushing the steer axle one way or the other instead of straight down the road. Now, the easiest way to solve that in our market, since we've almost all got 3-axle vehicles in this group, is to use all that weight and all that horsepower in the rear end of the vehicle to guide the vehicle straight down the road. In other words, you have a crowned road. Our guide for whether or not the vehicle is aligned properly for the crowned road is at 60 miles an hour in the right-hand lane from the center of the lane on a nice straight stretch of road with no wind. If you were to let go of the steering wheel, it should take just over 2 seconds before it gives into gravity and the right tire meets the white line. If your truck is not doing that, if it's going faster than that, it's got a pull that is going to cause feathering on your steer tire. If you have both drive axles pointed straight on a crowned road, the effect of gravity on those steer tires would be great enough to cause the feathering that we're talking about. So the only way to solve that we've determined after 30 plus years of effort in this, is to use the drive axles to just push it up against the crown of the road. We call it the Dixie cup effect, because if you lay a Dixie cup on its side and you roll it, the wide side rolls toward the narrow side. The same thing happens with the truck. The distance between the left and the right side, if it's wider on the right side, it's going to roll towards the crown of the road. And the amount that it rolls towards the crown of the road is directly affected by the amount that you've got it split. Our preference, our standard, is to have 1/32 inch shim off of straight ahead on the rear drive axle to the right, and a 32nd inch shim off to the left on the front drive axle. If you just have that very, very fine amount off the straight ahead, you'll get the handling effect that we want. If you have it a little further apart, you'll get, instead of 2 seconds to the white line, you get more like 3 or 4 seconds. If you have now spread both the rear and the front to a 16th of an inch each, you can get more like 7 or 8 seconds. You keep going, you'll get to 15 seconds. And finally, it'll actually climb the crown of the road, go to the left lane instead. And then around 10 seconds, we know you're going to start seeing feathering to the left instead of feathering to the right. So you've got that range of your performance of your vehicle. If it's more than 2 seconds, but less than 8 seconds, you're not going to experience any feathering on your steer tires. They're going to wear out nice and flat and smooth. So that's your range, that's your guide for for whether or not your vehicle is aligned right. All right, now last but not least, how can you get a vehicle that's only misaligned on one side? How does it feather only on the left tire and leave the right tire alone? Well, this is the way we always used to see the vehicles. Because, as I said earlier, nobody was accounting for the amount of play the steering components properly. They were all using slip plates and turn plates and everything else to set the toe because it was easier, but it wasn't accurate. So they were all towed out. And nobody could set the rear ends right because they all thought that they should be pointed straight, or you could vary off of straight in any number of ways from the front drive with the rear drive, and it wouldn't matter. So they almost all ended up with a right pull, because all but maybe one or two possibilities actually end up with right pull instead of straight or a left pull. So usually we find vehicles with a right pull and a toe out condition. So the right steer tire is rolling with the pull because it's towed out, and the left steer tire is collecting all the scrap. Lately, we've been seeing more of this because the manufacturers have changed their specs to account for that issue with towing. It used to be that 1/16 of an inch towing was your standard, but they've increased it to more like 3/16 of an inch as being acceptable. So now they actually are towed in too much, and they're still going right because they still haven't set the rears properly. So lately we've been seeing a lot more of this. That the result of those settings, a 3/16 of an inch toe in set, plus a rear end that's set as much as 3/16 of an inch off if it's within factory spec, results in a vehicle that scrubs the steer tire significantly. Like, for instance, every 1/16 of an inch shim we're talking about on the rear end, it missets the axle so that that axle pushes that steer axle sideways 1 inch every time the truck travels its own length. That's what our alignment system measures, is that specific angle. That translates to as much as 21 feet to the right every mile, or 40 miles to the right every 10,000 miles. So if you have a vehicle that's 3/16 of an inch towed in, and it's pointed to the right, the maximum for the factory setting of a Freightliner Cascadia, which is, in our scale, 3 inches or 0.18 degrees, I believe it is. That results in 100 feet per mile of scrub, or 200 miles per 10,000 miles of scrub on that poor right front steer tire. That's basically 1 state every 10,000 miles you've pushed that steer tire off to the right. Not a big state, but a state. Maybe like Kentucky talked about it. So that's the math behind the scrub that is destroying the tires that you've got. If you set it just a factory spec, but not within a range that's actually going to eliminate feather. So that's the difference between it's aligned and it's well aligned, is a good way to say it. These are our preferred settings. You can see a 1/16 of an inch toe in, only plus or minus 1/32. The front drive axle, we never wanted to point to the right. The rear drive axle, we never wanted to point to the left. And on our scales, we want about 1 inch between them, or a 1/16 of an inch shim between the two axles. All right. And that's it. No, that's not it. Good. I thought I left a bunch of stuff in. All right. The next topic is an issue that we keep referring to as a new issue, even though it's about 20 years old now. If you look at this tire, if you can see clear enough, there's no feathering on these tires. They are wearing nice and flat and smooth all the way around, except for that far outside right edge. The right steer on the outside edge is experiencing this awful cupping, but it's on a vehicle that was properly aligned. This started happening about 20 years ago, and it took us a few years to figure out what was going on. The axle manufacturers and the truck manufacturers got together and decided they wanted sharper turning vehicles. It used to be the average was 45 degrees, but they wanted more. They wanted 55 degrees. Now, as you can see, as the steer tire turns toward the inside of the turn, that Ackerman arm and tie rod are becoming an obtuse angle. around the inside of the turn is becoming an acute angle. Well, at 45 degrees, that was no problem. But when you turn it all the way out to 55 degrees, and I should have a picture of it, but I don't, I'll get a picture of it soon enough. When you get to 55 degrees, that active arm and that tire rod become a straight line. It has no mechanical advantage to hold the steering, that right spindle in place. The left steer tire, when it's turned all the way out to the left, still has the steering arm connected to the gearbox holding it still. The right side, the only thing holding it is that active arm and the tire. So it results in, especially when you're backing up and you now have negative caster on your steer axle, it results in a steer tire that's wiggling as you back up in a sharp turn. And that wiggle results in that cuffing that we're talking about right here. So I have a video of how this looks in action. This is a tire that's going from, I thought it was a video, it may not be, maybe it's just a picture. That's okay, but it's something you can do yourself. Just jack up the vehicle. It started with these, it's a Volvo VM. It extends to Cascadias, and now even the Kemmers and Peterbilts all have this wide track steering and the loose steering, or the high turning radius. And as you can just jack up the right wheel and turn it slowly, one turn after another. You'll feel that it's tight, it's tight, it's tight, and then when you get to the final turn, just before it hits the stop, it's nice and loose. The quick check is, the standard is that every turn of the steering wheel is 20 degrees. So if you can turn the steering wheel 2 times to the right, that's 40 degrees, and a little bit more is about the 45 it used to be. But if it's turning more than 2 1/4 turns, or upwards of 2 3/4 turns, now you've got you've identified that you have high turning radius steering, which is great, especially out east. And if you know that, then you can understand that this is the cost of doing business. But if you want to back that off, if you want to stop that, then you can back up this stop, which is circled here, and until it meets the embossment at 2 full turns. Then you won't be able to turn that tight, but you also won't get that wear on the outside edge of it. All right, any questions so far? All right, let's keep moving. Inflation. I have a lot to say about inflation. Way more than I can put in here. And the crazy thing is, air is free. I don't sell it, but it's the #1 cause of tire loss, of rapid tire wear. You need more air in your tires. And the better the rolling resistance on these tires, the worse they perform if they're underinflated. You have to increase inflation to keep your tires and make them last as long as you're paid for, right? Any tire, almost any tire today, can wear out nice and flat and smooth if you just take care of the inflation and the balance and the alignment. You can get to the end of its life and it can look nice and smooth and flat. They all can, but you need more air. Just as a guide, what it says on the side of the tire, that's let's see, it says max load 6250 at 120 PSI. That means that that's the minimum pressure you need to carry that load. If you're putting less air in that tire than that number calls for, then you're underinflated. Every 5 pounds you're underinflated, you're losing 20% of your tire's life. So if you've got a tire that says it should be at 120, but you're running at 110, you're sacrificing 40% of your tire's life just to be comfortable with the number. I mean, is it worth that? Maybe it is, but as far as I'm concerned, 40% of the tire's life is a lot of money. All right. So to look at that another way, on a 12,000 pound steer, you've got 6,000 pounds on each tire. But you can carry 34,000 pounds in your drive, 17,000 in each drive, or $4,250 pounds on each drive tire. So your drive tires are only carrying 4,252 pounds each. Your steer tires carrying 6,000 or more. Your drive tires are carrying 50%, or your steer tires are carrying 50% more than the drive tires. The drive tires are carrying a third less than the steer, however you want to say it. But the steer tires are often put at the same pressure as the drive tires, 100 pounds in the front and 100 pounds in the rear. Why would you do that? You're 30% overinflated on your drives, but you're 20% underinflated on your steers. The steers were the ones that are working alone, doing the steering, doing the braking now with the disc brakes. They need more air to do their job and to stay cool, to run longer. All right, moving on. I think this is the last topic. Inside edge wear on duals and wide-based tires. This is another big issue. It just keeps coming up, especially if you can kind of see the culprit over there. I picked on them a lot, but it's not their fault. It's the Hendrickson suspension of the trailer. It's there. They're the biggest in the country. They sell the most. So that's why we end up having to pick on them, because, well, they're the ones that keep building these things. So the issue is right here. You can see on the right, that's the old model of the Hendrickson LDA system. That LDA system stands for large diameter axle. And the old system was not a large diameter. You can see on the right, there's a black pipe that served as their axle. You can kind of see that it's actually a thick pipe. It's held in place with U-bolts. And the arm of that suspension is a 9-inch wide arm instead of a 7-inch wide arm. So on the new suspension, which is the left one, they have decreased the weight and increased the diameter of the axle, and now they weld it into the suspension instead of using U-bolts, because if they used U-bolts, they'd crush it. So they welded it instead. But the issue is that's a thinner axle, and it's experiencing flex under load, which is why we're ending up with this inside edge wear. As it rolls down the road, the axle's flexing in and out, and the bottom of the tire is scooting in and out itself, and it's causing that wear. The fix that we've found, which voids their warranty, so do it at your own risk, is to put the weight back on the axle that you took out by making it thinner. Add strength to it by welding angle iron to it. It works most of the time, not all of the time. Especially tanker fleets we're dealing with are just seeing no benefit from this. They need to go back to this larger axle, this thicker axle, to get rid of that wear. If you do have this suspension, you can do this. It does void the manufacturer's warranty, but the warranty wasn't doing you any good in the first place. All right, it's also happening on drive axles, which are not Hendrickson suspensions, but it's for the same reason. As you can see, let's see, there's a Kenworth over here. There's another Kenworth on the right side. I can't remember what the one in the middle is, but they're all experiencing it, and they're all experiencing it for basically the same reasons. It's a combination of two things. In this case, on the right side of the tire, or of the picture, you can see that's a Bridgestone 726EL, and that was the first time I saw this. It used to be any time I saw inside edge, inside dual wear on the drive, bench loose bearings. You just tighten up the bearings and it'll go away. But this specific tire, we couldn't do that. They were already tight, and we were still getting the wear. That's because they had changed the thickness of the axles. Here you can see it's happening on super singles. It's so bad on super singles, we think the heat on the inside edge of that tire is causing the recap to not adhere. So it's been a big issue. It is a big issue. The probable cause, as I said before, used to be loose wheel bearings, but it turns out it's actually axle flex. You can identify it by looking at the top of the housing. Most drive axles, if it's a Dana, you got to look up the specific number. But you basically identified it just by seeing the tire. As you can see here, the one on the left is a 9.5 millimeter thick axle housing. That's what the 9.5 means. That's how many millimeters thick it is. On the right is the old, was the standard 11 millimeter thick axle housing. Right around 1988, they turned the 9.5 into the standard. It saves 20 pounds, I think, per axle. So they took out 20 pounds of metal and left it with an axle that is causing all this flex. And then you made that, in 1988 we didn't even really notice it, but you made that flexing axle to a new low rolling resistant tire, and you end up with tread wear faster than you thought you would have. So your fix, unfortunately, is just to get the thicker drive axle housing. You're not going to be able to just weld. I've not yet met anybody who's going to weld anything onto the drive axle and expect to get it to stiffen up on it. Now, axles do flex. That was a video that apparently I only have a screenshot of now. It's the actual durability test. It's in Milan. I can't remember who. Yeah, this is Meritor. I don't know what thickness this axle housing was. It doesn't really matter. The point is, it flexes under load, and it's meant to flex under load. They do a billion cycle test on all of these types of axles to make sure that they will flex under load and not crack. So it was meant to do this. It's just affecting your tires adversely. And if you happen to have a wide base single and made it to one of these 9.5 millimeter thick axle housings, you're risking cracking that axle because now you've got too much stress on the end of the axle. So if you have a vehicle that has duals now and you're thinking of changing to singles, make sure you don't use the 2-inch offset. Make sure you use a 0 offset. And I think that's shocks. All right, don't have a lot of time. Shocks. What do shocks do on a truck suspension? Well, older style truck suspensions used a stack of springs, and the friction between that stack of springs would stop the bump, the flex of the spring as it rolls down the road, as it hops up and down on the road. That's the whole point of it. How do you get a spring to stop hopping? Well, you use friction. In the case of the old stacks of springs, there's friction between them and stop. But in the case of an air leaf or a parabolic spring, you don't have that friction. So how do you stop an air leaf or a parabolic spring from hopping up and down the road? Well, you add a shock. So the shock is the thing that is just the thing that stops your truck from bouncing down the road. It doesn't cause a tire wear pattern. It doesn't cause a handling problem of its own. It covers up whether or not your spring is good or bad. That's all it's supposed to be doing. That's typically all it does. So how do you know if your shocks are working? Well, the easiest thing is to look for it leaking. But then the next easiest thing is take it for a drive for 2 hours. When you stop, after a couple hours of driving, open the hood and feel the inner chamber. If the inner chamber is still warm, is warmer than ambient temperature, then that shock has been working, and it's good. If it's cold, it's not working. Easy check. That's when you change your shocks. You don't have to change it because it's been 6 months or because it's been so many miles. You change it because it's bad. If it's working, there's really no point to changing it. All right, and that's the end of it. We do have a podcast at 7.4 on the Lights Truck Network, and I guess that's all we got for you today. Do you have any questions for me? I'm really happy to have you here. I hope I didn't bore anybody, and I hope you learned a lot. Bye.